Hi guys. So today I want to talk about the greatest common divisor and the Euclidean algorithm, as well as how to tackle some questions that you may see on your exam. So what is the greatest common divisor, the GCD? Well, to define that, we first need to define what a common divisor is. So we say that C is a common divisor of A and B if and only if C divides A and C divides B. So the greatest common divisor, we could call that D of A and B if and only if two conditions hold. One, D is a common divisor of A and B, and two, any other common divisor of A and B is less than D. In other words, the GCD of two integers, A and B, is defined as the largest positive integer which divides both numbers exactly, right? So let's look at an example of how to calculate the GCD of two numbers. Let's find the GCD of 18 and 24. To do this, we can list the divisors of 18 and the divisors of 24, and we look for the largest or greatest common divisor, which of course gives us 6. Now, while this method gives us the greatest common divisor, it's sort of a brute force way. What would happen if we had really large numbers that we needed to find the GCD of? In this example, it is not practical to write out all the divisors of 492. So what we do is we break these two numbers up into their prime factorizations. As a side note, the prime factorization of a number, let's say n, as a product of all its prime factors. So for example, 30 can be written as the product of 2 times 3 times 5. And this is the prime factorization of 30. So back to our GCD question, the prime factorization of 108 is 2 times 2 times 3 times 3 times 3, which is 2 squared times 3 cubed. The prime factorization of 492 is 2 times 2 times 3 times 41, which is 2 squared times 3 times 41. So the GCD is the common divisors between these two numbers. That gives us 2 squared times 3, which is equal to 4 times 3, which is 12. So here's a quick visualization of why 12 is the answer. You could think of each one of these blocks as a factor of the number. So there are two sets of factors of 2 and three sets of factors of 3 in 108. There are two sets of 2, one set of 3, and one set of 41 in 492. So since each of these blocks are a divisor of 108 or 492 respectively, the greatest common divisor is just going to be which blocks are common to both numbers. So we have 2 times 2 times 3, which is 12. So what happens now when we need to find the GCD of two incredibly large numbers? Well, there's an algorithm we can employ to help us. So this algorithm, which is called the Euclidean algorithm, is going to take the pair 980 and 1072 and subject it to these steps. So first, to find the GCD of 1072 and 980, we'll write 980 first since it's smaller than 1072. Then we subtract. So we rewrite 980 and we're left with 92. 92 is smaller, so we write that one in front. 980. Then we subtract again. We have 92. And we have 888. Then we subtract again. We have 92 and 796. And we continue this process until we get 92. And then we'll get 60. 60 is smaller, so we write 60 first. Then we subtract, we get 60 and 32. 32 is smaller, so we write that first. And we keep on going until eventually we are going to reach 4 and 8, and then we'll reach 4 and 0, right? And this here gives us the GCD of 1072 and 980 being 4. Now, I did skip some steps, but you could verify it on your own, and you'll see that once we repeat this process, we are sure to get a non-zero number and the number 0 in our pair. And we get 4 as our answer. But as you could tell, this is a very lengthy process. So we introduce something to help shorten the process. So we have here the division algorithm, which says if we want to divide two numbers, a and b, we could write the larger number as the product of a, the divisor, by some integer q plus the remainder r. So, for example, let's say we wanted to divide 1072 by 980. Then we could write the larger number 1072 as 1 times 980 plus the remainder 92. So we're going to use this concept to speed up the Euclidean algorithm. So now we've tweaked the Euclidean algorithm using the division algorithm. And let's see how that is going to work out. So we start off with our pair 980 and 1072. These are the numbers we want to find the GCD. Writing in the form B is equal to QA plus R, we have 1072. 1072 is 1 times 980 plus 92. Then we go now, we take 980, we write that as 10 times 92 plus 60. We take 92, we write that as 1 times 60 plus 32. We take 60, we write that as 1 times 32 plus 28. We take 32, we write that as 1 times 28 plus 4. Take 28, and we write that as 7 times 4 plus 0. And we terminate it here when we get 0. So using this updated version of the Euclidean algorithm, we get that the GCD 980 and 1072 is 4, which is exactly what we got in our slower version. So the last thing I'm going to show you all how to do is to answer a question like this. Find the integer values of x and y in 1072x plus 980y is equal to 4. The first thing we're going to do is label each one of these equations, because that's going to help us out a lot in this question. We have equations 1, 2, 3, 4, and 5. What we want to do is write the number 4 in terms of 1072 and 980. So from equation 5, what could we write 4 as? We could write 4 as 32 minus 28. Now, from equation 4, we could write 28 as 60 minus 32. From equation 3, we could write 32 as 92 minus 60. And hopefully you all get the gist of what we're doing now. From equation 2, we could write 60 as 980 minus 10 times 92. And lastly, from equation 1, we could write 92, 1072 minus 980. Right. So where do we go from here now? So now, we could take each of these equations and backward substitute to get our result. So from equation 6, we know that 4 is equal to 32 minus 28. If we substitute equation 7, we'll get that 4 is equal to 32 minus 60 minus 32. So 4 is equal to 2 times 32 minus 60. Now, If we sub equation 8, we'll get that 4 is equal to 2 times 92 minus 60 minus 60. So 4 is 2 times 92 minus 3 times 60. Substituting equation 9, we'll get that 4 is equal to 2 times 92 minus 3 times 980 minus 10 times 92. So this gives us 32 times 92 minus 3 times 980. If we use equation 10, we get that 4 is equal to 32 times 1072 minus 980 minus 3 times 980. So this gives 32 times 1072 minus 35 times 980. So if we compare 1072x plus 980y is equal to 4, we see that x is equal to 32 and y equal to minus 35. And that is how we get the answer to this question. So all we need to do is use our equations that we used in part 1 where we found the GCD, and then we backward substitute until we get our answer. So that is it for this tutorial. I hope everything was clear. As always, if there are any questions, you could email me or you can message on the WhatsApp group. Okay, bye.